So for most of you in this room, today's speaker needs no introduction because he was a visiting professor at Hopkins for a year, a couple of years ago, and many of you took natural language processing with him. Others may know him from last year's summer workshop where he led a team on generation in the context of machine translation. Some of the older students might even remember him from a previous summer workshop where he led a team on building dependency parsers for Czech. So had it not been for this video camera, I wouldn't even be doing this introduction. So just for the sake of the camera, I'm glad to introduce Professor Jan Hajic. He is the equivalent of, I believe, associate professor at Charles University in Prague in the Czech Republic, and he is the director of the Institute for Formal and Applied Linguistics. And for those of you who may not know, Prague has had a long tradition of doing formal linguistics for several years or decades, I would say, and this institute has played a lead role, and now he is in that institute. And today he's going to talk to us about going from syntax further up to semantics, and they've been pioneering this this formalism, or this, I don't know, maybe I should call it a notation called Tectogrammatics. And this is to give you an edge into the semantics of the sentence over and above syntax. And he's going to talk about the Prague dependency tree bank and how all these things show up.
Yeah, hi. Welcome and good afternoon. And in fact, Sanjeev said everything almost, so maybe I can finish now. I would like to talk about, half of the talk will be more of a linguistic talk, and the second half will be why, not why, but that it still doesn't work. So maybe if you, this is not a good advertisement, I know, but so I will, but I will try to convince you that it has a potential for doing things that we couldn't do before with plain syntax. So what is the thing that we have actually done? You might have heard about what we call the Prague dependency tree bank. It's a project on building manually annotated tree bank of the size of the pen tree bank. And even though currently I call it a Czech language tree bank, so in fact we are building a tree bank based on the same formalism for a couple of other languages, namely Arabic and English. So I will say a little bit about that as well. So currently what you can have, you can simply get from an LDC a version of it that contains the morphological and syntactic annotation, and we are building the what Sanjeev already talked about, the what we call the underlying syntax, the Greek syntax, or we have devised the word tectogrammatical representation for that. At the same time, we are trying to build some machine translation resources. So in next year, hopefully, we will be able to have a CD with lots of machine translation resources like parallel text, parallel tree bank, and various other tools for doing MT. So, what is the basic scheme of the annotation? So for the Prague dependency tree bank, we have 3 layers of annotation. The lowest level is morphology. It is especially important for inflective languages like Czech, and I will show some examples why that's the case. The next level is what we call the analytical layer, and it's the surface syntax. Based on the tradition, we use the dependency syntax, but it's basically convertible to parse trees back and forth, and we have used that for our parsers as well. And the last level I will talk the most is the so-called tectogrammatical layer, which is something between syntax and semantics. So let's go briefly through the first 2 levels, and then I will talk more about the third one. So for Czech, for example, we have certain morphological categories that we have to annotate. So for English, probably we can identify maybe 3 or 4, like part of speech, degree of comparison, and grammatical number. But for Czech, we have many more. So the first 2, this is something like English. We have the 10 major part of speech categories like nouns, adjectives, verbs, pronouns, and so on. And then we have a lot of what we call a detailed part of speech, like the types of pronouns, personal pronouns, deictic pronouns, possessive pronouns, and all that stuff. We have several categories for gender. I mean, we don't really have 8 genders, but actually in Czech we have 4. Because the masculine gender is divided as masculine inanimate and masculine animate. They are usually considered 2 genders, at least from the morphological point of view. Then we have feminine and neuter and some combinations. For number, we have a singular and plural, and also in Czech there is dual. So for some words that refer to things that are usually come in pairs, like body parts, like ears, arms, legs, you have to use special forms in certain cases. Then we have 7 cases. I mean, these numbers here refer to the number of actual values of the category. Some of them mean not applicable, some of them mean anything. So it's not that Czech has 9 cases, it's 7 cases. And this is actually the most difficult category for both humans and the machine. And then we have some other categories that you can probably guess what they mean. As an example, if we take the form, I don't have the Czech word on the screen. It's called, okay, I can pronounce it. Nejnezajímavějšímu. And it means literally to the most uninteresting. And it's just one word. So the degrees of comparison are formed by inflection and actually by circumflex. Then we have inflection, and then negation is also formed by a prefix. So it's one word, and you simply have to get all the categories. So the first letter means it's an adjective. The second letter means is regular as opposed to possessive or whatever. The third letter is gender. It's feminine. This is plural. Case is dative. That's in English. It's the preposition. In Czech, it's just an inflection. There are several categories that are not applicable to adjectives. They are applicable to verbs or other parts of speech. And then we have the superlative degree of comparison and the negation as part of an inflection. So this is just an example. Together with the text, we also annotate lemmas. And lemma is a unique identifier to the morphological dictionary. So it's not just the stem of the word, because that would be still ambiguous. We have a string that's unique for the given part of speech, and for nouns it's also unique for the gender, because nouns typically have their own gender. So in English, for example, to would be divided between to-one and to-two. To-one meaning the preposition, and to-two meaning the verb infinitive particle. So that's enough for morphology. Of course, we can talk a lot about morphology, but I don't want to do it today. The second layer is the surface syntax layer. As I said, it's done in a dependency fashion. So the 2 things we add to the annotation here on top of the morphological tag and the lemma is the dependency, which is represented by the usual lines between the nodes. We call the lower node the dependent, and the upper node is the governor. So this is the link that says what is grammatically dependent on each other. Of course, again, we can talk what should be the dependent, what should be the governor. Typically, it's driven by the morphology in Czech. And the other thing we annotate here, the only other thing we annotate at this level, is what we call the analytical function. So every node in the tree, and there is, of course, exactly the number of nodes as is the number of words in the original sentence. So every word gets a function. And we have about 25 functions that are being assigned, but only 6 of them are kind of the major functions, like the predicate, something like an adverbial, of course, a subject. I don't see an object in this sentence, but we also have something like attributes. Full list of the functions is here. As I said, the main functions are just on the first line. We have a predicate, subject, object, and we don't distinguish object 1, object 2, everything is just an object. Then we have adverbials, again without really distinguishing time, location, or whatever. That's done later on. Attributes, verbal attributes, and nominal predicates. All the other functions are just labels for various types of function words. I mean, most of them, all those that start with the AUX. And then we have some special functions for coordination and opposition, things that are not really a pure dependency, but we still have to write them somehow. So again, I don't want to go into details for the surface syntax, just for you to get an idea when I will be comparing the surface syntax trees with the tectogrammatical trees. So the tectogrammatical layer has actually 4 sublayers. I mean, this division has nothing to do with the theory. It's just a division so that we can talk about it and we can annotate it. In fact, we also have 4 annotation teams, and each of them does one of the levels of the annotation. So the first sublayer is actually the dependency structure and so-called functions. And I will show a difference between the dependencies on the surface level and the deep level, and the functions on the surface level and the deep level. Then the next sublayer is the topic and focus, and again I will show an example what it means. Coreference is the third layer, and I won't talk much about the last, which is just bits of information that has to be filled in so that we don't lose anything. So what is the basic difference between the surface syntax and the deep syntax? So first of all, on the surface syntax, we kept all the words. And one of the reasons why we had that kind of basic rule that we shouldn't delete anything or add anything was that we can convert the dependency trees to parse trees. If we add something or delete something, it will be very difficult. We will have to have traces and all that stuff that's actually kind of very unpleasant when you do automatic analysis. So all the words are there, nothing is added. Here, since we want to go this one step further to get more semantics, we are deleting nodes, mainly the function words and other stuff, and I will show examples of that. But also we are adding things. And we are adding things where we have to solve ellipses and where we have to do other things that make it necessary to add some words. Also, the big change is that on the surface level we did not deal with with the semantics, so we had just one adverbial, one label for adverbials, but we didn't say exactly what type of adverbial it is. At this level, we already have a very detailed set of functions, so those 5 main functions are expanded to about 60 quite detailed functions. So if you know the Penn tree bank, it's kind of similar to the extra labels on the non-terminal nodes. You have like an np-subject. So I mean, we don't call it subject at this level, but also if you have an np location, so we have a location and so on. So that comes here. So here is a comparison of the 2 representations. This one is the same sentence you have seen before, and it has every word that has been in the original sentence is here, and we have got the analytic functions here. On the right-hand side is the same sentence annotated on the deep level. So let's have a look at some of the differences. So first of all, we have deleted the auxiliary verbs and actually collapsed this whole subtree, which consists of 3 nodes, has been underestimated into just one node, and that's labeled by the lemma of underestimate. Well, of course, the tense is preserved in the additional attributes I talked about at the last moment we add these things that are basically reflect the morphology, but only those that are relevant for the verb are preserved here. So this is one change. There is another change, namely that the functions are now converted to a different set of functions. And it's not only that those new functions are more detailed, but they are kind of normalized in some cases. So for example, in a sentence like this, which is passive, has been underestimated as a passive form. So in fact, it's not the influence, that's the actor. The influence does not underestimate anything. It was someone who underestimated the influence. So the influence is not the deep subject, but it's the deep object. And we call the deep object a patient. So therefore, we have the PAT abbreviation here. As I said, the auxiliary words like prepositions, conjunctions, punctuation are all deleted. So here we have the preposition on that's being deleted. Now you might wonder, how can we do that? Well, that's because the functions, like where is Europe? Here is Europe. Get converted to more detailed functions that kind of represent the semantics of the prepositions. And sometimes those prepositions are just a kind of a custom preposition for a given verb and the type of the complement. So we don't really have to keep them because we can learn what type of preposition is there. On the other hand, there are some nodes that are being added. And most of these additions are driven by the notion of valency. And I will show what I mean by valency in a second. For now, just let's say just intuitively that most verbs have to have an actor. There are a few verbs that don't, but most verbs have to have something that actually does the action. And there are some other types of verbs that also have to have a patient, and there are some other verbs they have to have even more complements. And all of those complements that we think are have to be present at this deep level. Of course, on the surface you can leave out anything, but on the deep level it should be there. So we simply fill it in as a general actor. There is another kind of semantically driven addition, and that's usually happens in coordinations. So in coordination, we consider ellipses if someone makes kind of a shorthand and talks about two things, but if the noun is the same, even if it refers to two different things, you don't simply repeat it. You don't say, like here, Central Europe and Eastern Europe. I mean, the grammar allows you to say Central Europe and Eastern Europe. I mean, the grammar allows you to say even more crazy things about two really different things. But even here, Central Europe is not Eastern Europe, right? So it's the same example, red and white wine. There is no wine that's red and white at the same time. Someone refers, well, could be, I guess, but, well, white wine is not white anyway, so whatever. But red and white wine is actually red wine and white wine. So again, we would insert this node because we think this is an example of analysis. Yeah.
You could send this all the way up to true, right? Because the influence on Central Europe isn't the same as the influence on Eastern Europe.
Yeah.
So
yeah.
How do you decide where to?
We usually do it on one level only. So we haven't found an example that would be that would really force us to think about doing it, all the way up to 3. Yes, we could certainly. We can divide. We can get rid of conjunctions, of coordination, disjunctions, and all that stuff just by pulling everything up. And actually, the annotators are told that if they see any problem, they are allowed to do it all the way up. But they haven't. They usually stop. So here is the, just to get an idea of what the set of function is here. So we have about maybe 60 functions total. The first line shows the typical complements of a verb. And these have the specific property that they cannot repeat for a given verb in a clause. It doesn't say too much, but it's just an interesting property of those 5. And then we have a set of another 50 that are what we call the free modifications. Of course, they sometimes can be kind of compulsory for a given verb, but in most cases they can be just with any verb or any noun freely in the sentence, thus the name free modifications. And then of course we still have to keep some special functions for coordination because we don't really multiply it up yet. For something we call the remmatizers, which is like only, just, whatever. And then we have a couple of special functions for foreign phrases, for names, for idioms and things like this. So let me go through some examples of the difference between the regular dependency tree, that one that's convertible to the parse tree, and the tectogrammatical representation of that. So one of those examples is complex verb forms. So it's similar to the example in the full sentence. The whole thing like this is just collapsed into a single node, and the modality and the tense is converted to values of attributes. If we have a passive like this, the book has been translated, then again it will be converted to a single verb. The book will be converted to a patient, even though it was a subject in the original sentence on the surface, because the book was the target of the translation, and there was some translator, we don't know yet, or we might know it from the context, but at the sentence level we just say it's a general actor here. Another example is how we deal with objects. Objects have no special marking on the surface level. We just say this is an object. But objects will get one of those 5 main functions. I mean, not 5, 4. Again, depending. If it's a passive, it could also get an actor. If it's not a passive, it gets one of the 4. In this case, he is the addressee of giving the book, and book is the patient. So book is what was given, and he is the one who received that. So this can happen to objects. This is an example where this is a different type of ellipsis, and again it comes up in coordination mainly. It's not the previous case when just people did it on purpose, just put together kind of the 2 Europes and just said one word. In this case, they simply left out the verb. And this is typical for Czech. If you have a coordination, you very rarely repeat the verb especially, if the verb is the same. So it's kind of a similar case, but since we don't like predicates without the verb, we simply have to fill it in. If we don't know exactly what the verb was, because sometimes this happens in the main clause and you don't know what the verb is. So we have a special lemma, or virtual lemma, for so-called empty verbs. We know there is a verb, we just don't know what the verb is. And unfortunately it happens often in titles, tables. It's very difficult to even agree between people what the verb could have been if it's explicitly in the text. But in this case it's quite clear. So we simply copy the lexical unit here. So as I said, most of these additions are driven by what we call valency frames. Now valency frame consists of a list of slots, and each slot is a functor and form pair. So the functor is the deep function, and it's always associated with a set of possible expressions on the surface. So that links the tectogrammatical layer with the surface syntax and with the morphology, because certain verb complements have to be in a certain case or have to have a certain preposition. So in Czech, we don't actually for give we don't use the preposition, but if it's in English, it would also have the preposition too. I mean, in English it would have. I mean, the dative will have to be considered compulsory only for pronouns. For other words, there will be just no case. But this is just an example of one of such frames. The thing is that every verb can have a different frame for different meaning. So for every verb, we might have several valency frames for different meanings of the verb, and even some subtle differences in meaning might mean a change to the valency frame. And this is actually one of the most difficult parts when doing the annotation, to decide what is the valency frame for a given verb. This must be a kind of an intuitive work, because there is no data that would tell us exactly, because there's nothing to do with whether the words appear on the surface or not. I mean, they often might be deleted, but what we use is what has been dubbed a question test. So the test works as follows. If you're not sure if certain functor should be in the valency frame, what you do, you say the sentence without that slot filled. So like say, I'm coming, right? So you are not saying where to you are coming, right? And then someone kind of asks you, so where to are you coming? Where are you coming to? And if you can say, I don't know, then it's not compulsory. But if you can't say, I don't know, then it is compulsory, right? So if you say, I'm coming, and someone asks you where to, and you say, I don't know, that's crazy, right? If you are coming, you have to be coming somewhere. I mean, nothing is foolproof, but this seems to work very well. So people can agree that it's crazy to say, I don't know. I mean, it's very difficult to agree kind of ideally what should be in the frame, but because the question is, yes?
Just to clarify the example, are you saying coming and going would be different in that respect?
Probably yes. Yeah. If you are going, you are going. You don't.
Could be just leaving and not to where you're going.
Yeah. But for coming, it seems to be the case that you have to. Similar for actors. If you say it's raining, you don't have to know who is raining. There is no one who is raining, or nothing that's really raining. If you say with other verbs like going, then you know that someone, who is going. You have to say who is going, otherwise it's not possible.
So the resolution of this missing functor need not be in that sentence or even in the immediate context of that.
No.
It's just have to agree that if for the sentence to make sense, between the two people talking, there is an understanding.
Right. I mean, one could say semantically, you should be aware that there is something who is going, or there is a place that the person who is coming to. But it doesn't have to be in the text. It usually is, previous sentence, 20 previous sentences, whatever. This is worst. This is the worst if these things are usually not expressed, and then it's a question whether it's already contained in the verb that it's something. I'm cooking. That's the example we can never agree on. If you are cooking, do you have to be cooking something always? If you say I'm cooking, and the question is what are you cooking, and you say I don't know, can you say that?
You could just be throwing things into a pot. At least you know what to try.
But someone has to, eventually it will be something, right? But then you have a sentence that you say, I am cooking for my grandmother because she's so ill so that she cannot cook for herself. Are you really saying you are cooking something, or are you saying I'm usually cooking something for my grandmother, but that's something else? And I mean, I don't know. I don't want to say.
So I cook every night at 6 o'clock. That doesn't apply to the food.
Well, you have to cook something if you say that, right?
But it's a generic.
Right, because it becomes so general.
Yeah. No, but I'm saying that sometimes it's very difficult to decide whether there must be. I mean, normally you would say yes. If you cook something, you have to cook something. That the verb cook implies that there must be something you are actually cooking. But But, you know,
Right, and
it's
there
kind
has to
of,
be someplace that you were actually going, even if you don't know.
you don't have to know if you're just, as Charles said, you're just leaving.
Right.
But this does create a problem, namely that if this whole notion of annotation has to work on sentence-sized units,
Yes.
then the decision about which frame to use can't be made just from that sentence. You
Oh, no,
need
no,
to
no.
refer to
Yes.
things around it. So in
That's-
some sense, this is not an annotation of the sentence.
No, no, you will see on the other levels it's also, I mean, it's annotation on the sentence level, but in order to decide, you have to know the context. But in fact, part of speech is the same thing. I mean, even if you are doing part of speech, it's not a word level annotation, because from the word itself, you are not able to do it, right? So, not even from the sentence sometimes. So.
Is there any crossing consensus on whether the annotation is obligatory for Cook? In other languages, do they typically require Cook?
Well, we don't know. There is no valency dictionary for any other language. I mean, we can look at the preposition bank, for example. We have the verbs from UPenn, but they don't really say what is obligatory and what's not. So for cooking, yes, it's there, but and it's called an argument. So one would say yes, this is obligatory, but there is no such sentence as I said, I'm cooking for my grandmother, or I'm cooking in a school cafeteria, right? You are not saying you are cooking something. You are talking about your job. So again, this is the question. Yes.
So can actually hurt if you add this even for cooking, for example, right? And you just have the general thing. And if you cannot get the semantically from the context, well, if you want to do translation, you're just going to ignore that part of cooking, and you'll say it should be.
Well, it depends how we would treat this for some application. I mean, of course, if you put it there, all these filled-in nodes are supposed to be filled by co-reference. I will talk about co-reference later. So if you add too much, then you will be in trouble because you are kind of supposed to resolve the co-reference for all of these nodes. On the sentence level, they might be labeled as general, but you know they have to point somewhere.
But can you have some default objects, right?
Yeah.
I know. I mean, it
Whatever,
depends on
yes,
the.
This seems only important for cases where you have to actually distinguish between two different senses of a single verb, right? So like, you know, I mean, cook in English in the sense of like, oh, you know, I'm cooking, you know what I mean? Like, I'm actually, and it doesn't have anything to do with cooking anything,
Yeah.
and I know I'm not actually cooking anything in the other sense. I mean, and the same applies to the verb come. I mean, you know, there's two senses there too, I mean, that way. But, you know, are there other verbs where, I mean, it actually is not important because there's not that many different senses that actually would, or that it's actually, it doesn't matter, actually, to even ask the question.
Well, it's, I mean, we try to be minimal in the sense that we would not create obligatory slots in the frames if we are not quite sure that it's really obligatory. Because, as I said, I mean, eventually we would like to have an invariant that all of these general nodes are actually resolved. And if we have too much trouble with that, we just give up. Okay.
I
Yes?
guess frame semantics treats that issue, where you actually are cooking something, but that's not the focus. When you're talking about it's your job and that sort of thing. I think that is dealt with in case grammar and frame semantics.
Yeah, I mean, eventually we will have to deal with the cases where we cannot resolve the reference, and then we simply leave a star or something. Yeah. Okay, so that was the first level. So we have a deep dependency tree, and we have these detailed function labels. The second sublayer deals with what we call the topic and focus, or deep word order. Now, what do we mean by deep word order? We believe that in every sentence, you can order the words or the constituents in the sentence from left to right in the order of what has been already mentioned before or what's known from the context. to the thing that actually new in the utterance, in what is the new information in the sentence. And what is the most known, what is the most, what we call contextually bound, goes to the left, and what is the most new goes to the right. Well, of course, the order is sometimes kind of, we don't have very good rules how to do it constituent by constituent, but typically we can divide the sentence at least into two halves. One, the left part is the context, is something that has been already said, is the old information, and the right-hand part is the new information. And this applies at every level of the tree. So if you have a noun and adjective, typically the adjective is the new thing and the noun is considered to be the old thing, but it also depends on the whole discourse. So the nice property of that is that we believe that if we order the sentence like this, we can get rid of so-called non-projective constructions, which are kind of a nightmare for dependency representations, because it happens, and it happens in Czech, it happens in English, that in the pure dependencies tree, if you keep the original word order, you get crossing dependencies. A dependency above which you have some node that's kind of, that if it's projected, it crosses the dependency link. If we do this, we believe this doesn't happen anymore. So it doesn't happen that the old information will kind of cross with the new one in this respect. Of course, that way we get rid of the original word order. So the deep word order is really the information order. It has nothing to do with the surface word order. So for example, if you do generation, you have to restore the surface word order based on various criteria, the grammar, the intonation, whatever it is in that language, the whatever. In Czech, it's interesting that the surface word order very often follows the deep word order, except for a couple of grammatical rules that simply dictate how to do the word order. For example, adjectives have to come up before nouns. That's just a fixed rule. Unlike Polish, for example, when there is a special rule where the adjective should go, but in Czech there is a fixed grammatical rule. So it's kind of similar to English that the subject should go first and then the verb and then the object, even though it's not 100%. But again, in Czech it's not 100% either. But it's like that. But most of the other components can go in the deep word order, and it's fine for Czech. And actually, it's the way how Czech deals in written text with the question, what's new, what's old. They simply use the word order to say, this is the old information, this is the new information. In English, it's more difficult because the grammar constrains the word order, and therefore you have to use the intonation. And in writing, it's kind of difficult. So in writing, you have to use things like extraposition and some other things that make English a little bit more free word order or closer to it.
And sort of touching on the question Sanjeev brought up earlier as to tagging at more than the sentence level, taking the graphical, or the utterance sentence as your basic unit, how does, for example, take some example, coordination interact with this old new distinction? Where in the second part of coordinated construction, the old and new information is different than it is in the first half of coordinated construction.
I mean, definitely for the correct annotation of topic and focus and the deep word order, you have to know the context. I mean, there's no question about it. There are some things inside the sentence that can help you to do this correctly. But again, in Czech, it's the surface word order that helps you quite a lot. But in English, there is not much that helps you, right? So yes, I mean,
but it's made more difficult by saying, well, we're going to tag an entire sentence all at once, instead of saying, well, actually, there are two constructions here, and they both have their own old, new, new information, old information structure.
I see, but we have to do the same with things like coordination or subordinate clauses, because again, they can be, the order of that could be different, because a subordinate clause could be both new and old, so it sometimes has to be changed for this annotation. So So in fact, the topic and focus is one of the important differences between the analytical layer and the tectogrammatical layer, because the order on the analytical layer is the original word order. You have still all the words, and they are ordered in the same order as on the surface. For the tectogrammatical layer, the word order is driven by the old and new, by the topic and focus. So here is an example. If I mean, in Czech this would be expressed by word order. In English, if you say baker bakes rolls, it would normally stay like this because you are simply talking about the baker and what the baker does and what is actually the result of baking. But if you say baker bakes rolls, then actually you are putting the stress on baker exactly because you want to say that it's the baker who bakes rolls. So the context is that there are some rolls being baked, and then you are saying, and it's the baker who does it. So you can imagine that if someone asks what the baker does, you use just the normal intonation. You say baker bakes rolls. And if someone asks who bakes the rolls, then you have to say baker bakes rolls. If you say baker bakes rolls, it's kind of strange to stress rolls if someone is asking about rolls. So if, I mean, again, for annotating English, this is a nightmare because there is no intonation in written texts, and you have to really understand what's going on. And actually understand the pen tree bag, for example, is pretty difficult. We'll see. So the current status of things is the following. We have about 400,000 words annotated at the tectogrammatical layer I just talked about. We are working on co-reference and topic focus, and that's been started, so we have about 10,000 words. For the rest, like tenses, we have an example sentences, but most of it can be done automatically, so we will probably be done with most of it for the full thing. The plan is to have 55,000 sentences, which is half the original tree bank. I mean, we don't really want to waste another 2 years doing the other half. So we'll see how far we can get with half the size, and then possibly have a partial. And at the same time, we are trying to define what the tectogrammatical annotation should be for German, English, and Arabic, because we think it will be actually pretty close to Czech. Maybe the set of functors will have to be extended by 1 or 2, but not massively. That's our belief. I mean, we have examples for English. We have the pen tree bank has been converted to this level, but only automatically. And we know it's not possible to do it completely automatically. We have done some experiments for German on the Negra corpus, because they have some information for the functions like the pen tree bank. So we can, again, do most of it automatically, but again, it cannot be done fully automatically. And for Arabic, we are in the phase of actually defining and looking at Arabic, how well it can follow the Czech definition. And it seems it could, because for the surface syntax, very surprisingly, Arabic was quite easy to fit on the Czech style dependencies. So that's it. Now, what are the future plans with this?
Sorry, I have a question.
Yes.
So as you sort of went deeper towards syntax, from the dependency to adding these implicit subjects or objects or other things in the frame, but choosing the particular frame to then getting the deep word order. I guess it's going to get harder and harder to get agreement between labelers.
Yes.
So how do you measure this? With the dependencies, I can just count and see how many of them agree.
Yeah.
But for example,
well, technically, this is not so difficult. Of course, it's a bit more difficult if you have 2 trees that are not guaranteed to have the same number of nodes. So we have to have some measure that says how these 2 trees compare. But that's solvable, kind of, with some heuristics and other things. Kind of find the best match between the 2 trees. But of course, it's just the technical part of it. The inter-annotator agreement on the dependencies and the functions is about 90%. So it's not great. We would like to, be better than that, of course.
functions?
That's just the dependencies and the functions.
labels.
But that includes inserting these general, the filled-in nodes and other stuff, right? So people typically don't agree on a frame for a given verb, and that counts as two errors, basically. You have a wrong dependency and a wrong label. And that count is about 90%. For the topic and focus, we have done some initial experiments, and people do agree surprisingly more than on the dependencies and the frames. But there was, I'm afraid, due to some of wrong formulation of the rules that simply forced the annotators to do something which I don't think is right. So we will have to we are revising the rules at this moment, and we might get more disagreement because the people were told, if you see this word, that's the middle of it, right? And it might not be, we found, in some cases. Actually, the annotators came back and said, well, okay, this rule is fine, but I think, this is the old information, not the new one. So we have to rethink the rules. For the co-reference, that's actually the best. Goes fastest. It's surprising. And people are able to say, who is that he very easily. Even if it's 5 sentences back, that works well. So the worst thing is the functions, That set of 60 functions, they are not really, that cannot be clearly defined in some cases. So you have manner, you have some specific types of manner, and people cannot decide. The same with time. It's very difficult to distinguish between parallelism in time. Like while being in the mountains, I did cross-country skiing. So that's kind of a two parallel actions, but it could be regarded as a simple time. So at the time I was in the mountains, I was skiing. So it's an answer to a question, when were you skiing? When I was in the mountains. So, and that's difficult to get from the text, whether the person who writes about it really thinks in the category that he wants to stress that these two things run in parallel, or whether he wants to say that it was just at this time when the other thing happened. So what is the future? So when I say we want to do semantics, of course we have to do lexical semantics as well. We are kind of doing it with the verbs, with the verb frames, and with some of the noun frames. But it's not quite the same thing as doing the full lexical semantics, because even if two verb sentences could behave syntactically the same way, they can have the same frames but still have a different meaning, obviously. Right? They can have an actor, patient, that's it, but they mean two different things. So we are using the WordNet for Czech. That's part of the Euro WordNet, which is a collection of languages that's linked to the English WordNet. It currently contains only 50,000 nouns and 4,000 verbs, but fortunately they were chosen based on frequencies, so we can cover most of the text. And we have found various problems and are working with the people in Brno who are actually doing the WordNet. So we should have, I don't know how many by the end of the next year. Hopefully, reasonable part of it, so that we can also make it part of the sensible task and be a little more hard than the last one we had only for the juridical terms that were distinguished. The next task is, though, to go what we call level 4. Like we have the morphology, analytic level, and the tectogrammatical level. We would like to do something more universal, in the sense that once we have these 4 languages, we would like to try to make a unique representation. So it won't be a big change. It won't be a logical representation or predicate or whatever, lambda calculus. It won't be like that. But it will be something that should be universal, at least across those 4 languages I mentioned. So things like name resolution, numbers, dates, all the stuff that's normally being done very early in the process, we believe we can do it more easily once we have the syntax down, because sometimes the syntax still plays a role in those. The other thing is that we should check the topic and focus and the co-reference, whether they are really identical for those languages, or whether we should redefine something to really make it identical. So it's, of course, this is all driven by machine translation. So if you want to have one representation, they will be kind of identical except for the words across languages. But this is just a speculation at this point. So, and of course, since we have it for some time, we have various tools. So this is more of an advertisement if you want to do experiments with it. On the CD we distribute, there are lots of tools for morphology, tagging, parsing, and there are also some tools for converting from the analytical representation to the tectogrammatical one. But this is kind of partial. I mean, we don't have a real parser because we still don't have the data, so we can't train on anything. This is just rule-based. But now, let me use the remaining 15 minutes or so showing why we think this is kind of worth doing. So one of the reasons is obviously machine translation. We believe that if we have a deeper representation of the sentence structure and the meaning, that we can do better machine translation because we will have much less work in the transfer phase. And if we have a real common representation, then we have almost no work in the transfer phase if we do word senses right and everything. But of course, it's compensated by more work in the parsing phase and the generation phase. And as I said, I mean, so far it doesn't seem to work very well. But just imagine that after the European Union expands by the next 10 countries or whatever, that the number of pairs of languages they are supposed to translate to will be over 600. So if you imagine that you really have to translate, for every language to the other languages, it's kind of too much. So we believe that eventually this will simply have to be the way to do translation. Yes?
I was speaking with someone in England, they told me that right now they're not translating anything anymore.
It's true that they are not translating everything as they were, even for those 15 languages that they are there now. But still they are translating a lot of that stuff. Have you been in Luxembourg? Do you know what's the biggest building in the European Commission?
It seems that it's not available for research purpose. So I was speaking with someone.
Oh, you mean the text? Yeah, because they are doing on paper. I mean, that's the thing. I mean, no, the Commission is using Sysrun, but the Parliament is doing things on paper. Okay, so what is the general scheme? Now, there are systems that use parsing for translation, but what I'm proposing is to actually do a little bit of parsing to go from the surface syntax to the deep syntax, and just have this transfer actually, shrink as much as possible. But of course, then it's at the price of doing this additional parsing and this additional generation from tectogrammatical level. Now, in order for this to work, it would have to be true that the two tectogrammatical representations for the two languages you want to translate to are kind of close enough. I mean, we know that the tectogrammatical representation is not an interlingua. I mean, there are still differences in the trees. For example, for a word like typewriter, which is one word in English, it's usually two words in other languages. In Czech, it's definitely true. In German, I think it's just one word, but German is known for these. But in other languages, it's two words. So one can imagine that there are many correspondences like 1-2 or 2-1 between the two languages. So we have done some experiments between Czech and English, and these experiments were done on Reader's Digest. So Reader's Digest stories are kind of novel type of stories. It's not really a technical literature, nothing close. And in fact, the Czech translations are good translations in the sense that the translators try to be nice to the readers and make it really Czech-like. So these are not literal translations. So in the original translations that we actually got from Reader's Digest, only 50% of those note correspondences were one-to-one. And we had kind of, small percentage of those still kind of nice correspondences, like 1-to-2, like the typewriter one, or some extra notes that were simply left out in the other translation, or the opposite. But unfortunately, we had about 90 other types. By a type, I mean 1-to-2, 3-to-4, 5-to-6, whatever, right? And there were about 90 types, but all of them were seen in 100 sentences only once or twice. So this didn't look good, right? But then we said, well, but this is kind of too little. I mean, the problem is we don't have any other corpus at this moment. I mean, we are translating the Wall Street Journal, but we haven't had it when we did that. So we only had the Reader's Digest. Then we tried to retranslate those 100 sentences by someone who was told, please do it kind of literally, but still produce a grammatical check. Don't do anything that would be against a good grammar and good style, but don't try to do it in the, literally in the sense of a literature, right? And then we found that actually 90% of those correspondences were of the relatively easy types. Most of it was 1-to-1, and then we had some 0-1. The rest is still bad, but we only had about 40 types. 40 types and only 10% of the correspondences. So we believe that for technical texts and economic news and even daily news, it could be rather that case and not the upper case. This was more like a novel. For novels, we don't really want to do it. So here is an example. The sentence was, in this mic, Les began to sing. It's just one sentence from the middle of a story. The original translation was quite good, but it didn't say who started to sing. And moreover, it said then. There is no then in the English sentence. So the difference is that we have this extra note here in Czech, because that says then. And we have a general, what is it? Oh, here. We have he as a pronoun here in the Czech tree, and we have the name here. And that's not so bad, but still, how do you get that? So this sentence is the retranslated sentence, and that's now identical, and I think it's a perfect check. There is no, even if we look at the story, it's not so bad to use the name instead of the pronoun. It's not that Czech would kind of prohibit to use names often. It could use them. It was just that someone thought that this is slightly better sentence than the original one. So again, of course, this is one example, but most of the sentences look like that after the retranslation. Here is another example that shows something different. This is an example from Arabic. And these two trees are the surface trees. So if you imagine that you want to do machine translation on the surface syntax level, that this is roughly what you get. You have to convert this tree to this tree if you want to translate for Arabic. And there are several differences. So first of all, the word order is different as expected, right? So the subject here is in English is the last word of the subject constituent. In Arabic, it's the first word. Then, if you look like here, the order here is also quite different. And in English, the apostrophe is down here. At least that's how I would interpret it from how it's done in the pen tree bag. In Arabic, they say it's the other way. This is almost the same, but there is no article here because it's the definiteness is encoded somewhere. Don't ask me, but So there are many differences between these two trees. If you convert it to the tectogrammatical representation, so first of all, the trees are much smaller because we get rid of these function words and all that stuff. And also, the trees are the same. I mean, the structure of the tree is the same because now you have the freedom of doing the deep word order just by the discourse. There is no tie to the original word order. And by the usual compression and additions, you get the same tree. I mean, again, this is an example. It's not always like that. But we are now getting some parallel text on English and Arabic. So we're going to do a similar experiment as we did for Czech, seeing whether if we draw these trees basically by hand for English and Arabic from those real translations, how close we get with those correspondences, whether we will again get only 50% of the nice ones or whether we will be closer to those 90%. And here are the numbers. They are not very optimistic, but let me explain. So first of all, what we have done, actually it was Giza++. With a very large language model, which can be trained like 100 million words English language model. And what we got was like 0.19 BLEU score. I mean, I don't have to explain what the BLEU score is, right? It's just a measure for matching two natural language sentences, how close they are if you have a set of reference sentences. So we got to 0.19, which I think is a quite a good number because the human score is like 0.55, and we only have 5 translations, 5 reference translations. We also try to do a commercial product, and there is one, this is the best commercial product on the Czech market for doing Czech and English. And it actually was slightly worse on the def test, was slightly better on the eval test. So I don't know what this says, but I think it says that actually the commercial tool is not so bad. Even though if you look at it, it's not so nice, but the Giza is not so nice either. I mean, it's kind of, if you look at it, it seems same quality. The rough baseline, if you do the full translation using the tectogrammatical layer, but you only translate the lemmas and keep the Czech word order. So this is probably the worst you can do and the simplest you can do. Just translate the lemmas. Don't add any articles, any prepositions, any inflections in English. Just don't do anything. Basically print it out. So these are the numbers. So you can see the difference. This is about half of it. The summer system with some modules just hacked in because we didn't have the time was actually slightly worse than that baseline. But we are getting up quickly at the end of the workshop. So we still believe we can do much better because at least we will have some of the articles right and some of the prepositions right, which we cannot get by just by the baseline system. But we did some other errors that this system would not do. And the improved workshop results will be published in Budapest at the European ACL, and they are better than the baseline. Finally, actually quite by far in the eval test, but they are still only half the results of the Giza system.
Is the baseline a gloss, just a dictionary gloss?
Yes. The baseline is, well,
Replace
it's not just the gloss. It's the most probable gloss based on the type of the text. So actually, we have taken the Wall Street Journal. We had like 200,000 words translated, and we got the best translation from there. So it's not just a random gloss. I mean, these numbers. They'll be lower, yeah.
Is the topic decided based on you decide to classify the topic based on the thing?
Well, all these experiments, I mean, we have created these test sets, and they are quite expensive to do. So this is only for the business news from Wall Street Journal. So the test data are 250 sentences each of the sets from the Wall Street Journal sections 23, 24, 22, 23, 24.
And the training set for this, for your system here, was it originally English translated to Czech or vice versa?
Yeah, it's English translated to Czech. Yes.
And you're doing Czech to English translation.
Yes.
Do you think that direction has a big influence on the?
Not quite. I mean, English to Czech would be even worse, I think, because of the inflection.
Yeah.
And based on the blue score criterion, which looks at words, but if the word has one letter wrong, it's the same error as if you have a completely wrong word. So, you know, the inflections are kind of bad for that counting. For the training of that system, we had about 200,000 words for the, you know, for the generation model. That was very small.
And just is at the tectogrammatical level,
yes.
A lot of these 1 to 3, 1 to 4, 5.
Well, actually, for the generation, which is the key part of this, we only considered 1 to 2 because of the small data. So we couldn't even do like a preposition and a determiner. We could only do one preposition and one determiner, and only for a small set because of efficiency problems. So
when you're talking about the arity of those mappings, that's at the analytical level, not the tectogrammatic.
The arity of the mapping I talked about was between the two languages. But for generation, you have basically the same problem. You have to have 1 to 1, 1 to 2, 1 to 3, 1 to 4, 2 to something mappings. So it's a very similar problem. Okay, so this is empty, and let me use the last 5 minutes for just a speculation. This is an old project. We actually worked on 21 years ago, 22 years ago. At the time, you can only use the assembly language version or something. So the ideas are very old, but I think now it can be implemented. I just want to show again why I think it's good to use the tectogrammatical representations. So for targeted question answering, we think we can use a matching on the tectogrammatical level to get very high precision on the answers. So if you have a question, who was the king of France? So the tectogrammatical representation of that sentence is here. And I only show the lemmas and the functions. And now let's suppose we have a huge amount of data that are all analyzed at the tectogrammatical level as well. So this is one of the possible sentences. And by chance, this is one of the, I mean, the number is probably wrong. I just made it up there. Whatever. So this is one of the possible sentences. Now, how do we find out that this is the sentence that should be shown as the answer? So first of all, we have to match it. So what do we match? Well, we have to match everything from the question, except for the question for the WH word, right? But we have to match its function. Now, the matches could be either exact, like king and patient, and France and France, but they also can be partial, like be and become, like synonyms can be taken into account, or should be taken into account. And if we find a match like this, if the question is a subset of the answer, of some sentence from the data, then we actually can get the answer. And we get it in such a way that for the WH word, we simply extract the subtree that corresponds to the WH word. And that should be the answer. So of course, this only works if the answer is presented as a real answer to your question. If, for example, someone says, and then France got the king, the Louis XIV as its king, that would involve some more sophisticated thing. Yeah.
I'm sorry, how is the mapping from B to become done? How do you know that B maps on become, that kill doesn't?
Let's say, okay, I will show you, this is the point. We have to match the subtree with, from the question to the answer. And of course, what we Okay, now it's on the next slide. So we have two things that we have to do to get reasonable recall. First of all, we have to use synonyms. So be and become could be considered synonyms or quasi-synonyms, so we can use those for the matches. So every word can be matched, like king could be the emperor, or whatever you can think of as a possible synonym. And these are very simple matches, just node by node. But then, of course, for some things you still have to use what we call inferencing. So, for example, if you say that France got Louis XIV as its king, it should kind of correspond also to the sentence that Louis XIV was the king of France, right? And so you can imagine that there should be some kinds of kind of tree twisting or tree correspondences going on that should either expand the query or expand the answer. Based on the practical considerations, it's probably not practical to expand the answers because you are supposed to have a huge database of text, but it's better to expand the question and then try to do the match on the answers. Again, this leaves out completely the case when the answer is actually contained in two sentences and you have to merge them together. And we have been trying to do that, but because this works on the answers, which is a huge database, it's not trivial from the efficiency point of view. I mean, theoretically, you can come up with solutions, but we don't think it's practical at this point. The interesting thing is that you can get also partial answers. You can imagine that you will have a sentence that says there was, that someone was a king, but not king of France. So the subset, the question is not a subset, but there is a big intersection of the question and the answer. So the system can say, well, I don't know who was the king of France, but I know that Pierre the First was the king. So maybe at least I give you this information, right? You can do things like negation. You can forget about negation, right? So you say, I don't know that I don't know who was the king of France, but I know that Charles IV was not the king of France because I found this sentence with that no, right? So you can think of all kinds of possibilities, which are actually very simple transformations on the tectogrammatical level. There's a very old paper about the topic, so which talks mostly about the inferencing, because that's kind of the crucial part. Okay, so it was just a speculation. Eventually, we would like to make a project like this, but no one has applied to do that yet. Okay, thank you. So, any more questions?
This is more of a comment. So, if you could somehow embed importance, for example, in the cooking thing, right? You just consider the complete frame all the time and just look at how many times you could actually resolve that frame. You can say, I know, this is, I know, 5 of 10, that's the importance coefficient in this case. And then that can work for things like King of France, because France is very important here. Right, so you can know that for king you must have the country, because otherwise it's meaningless if you just say Pierre the First was the king.
Well,
right? That would be just a way of taking all the time the most complete frame and trying to see how many times it can be resolved.
I completely agree. I mean, the theory of valency frames is actually very old. I mean, in the linguistic theory, it has been present for a long time. I mean, and many other people, not just in Prague. I mean, Fillmore has done, case, and other people, and preposition bank is being done now. But I think after all these experiments are done, someone has to have a look at it and say what is actually a valency. What is it good for? We don't know yet quite. I mean, people claim that, similar way I claim that tectogrammatical level is good for question answering. Some people claim that valency frames are very important for parsing. I'm not so convinced yet. So maybe the whole theory will have to change a little bit. in any case, it will have to change from this black and white, the slot is compulsory versus the slot is not compulsory. We will have to some kind of a degree, like usual, right? Some probabilities. So I don't know yet. I mean, it definitely has to do something with the surface presence and with the coreference linking, whether it's possible or not. Yes, exactly. You had a question.
I just had a comment that this is probably not the best example to show for motivating, because the bag of words would actually get the answer for you very well.
Yes, no, I agree. I mean, I know. But if you remember the experiments, there was a workshop on question answering. Yeah. I don't know where it was, but some ACL.
Mark Light.
Mark Light, yeah. And no, it was not Mark. It was Eugene Charnik's students, I think. They did some project.
You're talking about the ACL one.
Yeah,
Yes.
yeah. And they actually got an improvement if they combined several methods, right? They didn't get much improvement, but one of the improvements was that they actually looked at the predicate verb. And if there was a match between the predicate verbs, it kind of helped a little bit, as opposed to backward words or simple techniques. So, I mean, this is not a method that would give you a huge recall. It won't. But it might give you kind of this type of answers from small data, like the reading comprehension tests. This might be, for some of the questions, it might be good. Again, it's not good for why questions. There's a lot of inferencing going on in order to get a better answers. But for, who, where, it could work. Especially if you only want short answers, this 50-letter the 50-character evaluation, that might be. Yeah. Or even better, the exact number of words or something.
I'm going to throw in my chips with Sanjeev. I think the problems in question answering aren't necessarily syntactic and inference. So, because I didn't try this, but I tried grammatical transformation. So maybe if you had to frame rules that would help just so. It seems like you could spend a lot of time.
I mean, I agree that usually the improvement over these simple baselines is not big, but it's just, what I think it might be the most interesting part of it is that actually the inferences are kind of easier to do at this deep syntax level than surface or something else, because you already are closer to semantics than otherwise. I mean, the simple match is just a nice example you can show on the screen, but of course not many answers are present like that in the data. On the other hand, you can imagine that you can convert databases very easily to these trees. It's kind of trivial, so you can combine text and data again by using something like this.